Alright, it's actually not too bad of a section, a little bit of review, but also a little bit of an extension from what you already know. Focuses on right triangle applications, so most of what we're going to see, at least for right now, will be dealing with right triangles. Okay, so that means, for example, if you have a triangle like so, let's say this is 10 feet, and let's say this is a 20-degree angle, and maybe you're asked to find this height. Okay, or maybe you need to find the hypotenuse, but either way, you already have a way to do this. In geometry, for some of you a couple years ago, for some of you last year, you paid attention to the angle, which is right here. And we've been working with these ratios already, so it shouldn't be too bad. Across from 20 degrees is the opposite side, right? And right next to it, not the hypotenuse, that'd be the adjacent side. So according to this, I should be able to set up a trig ratio, which would be, since I have opposite over adjacent, tangent of 20 degrees will be equal to opposite, which is h, over adjacent, which is 10. Okay, and then now you can solve for h. So you'd have 10 times tangent of 20 degrees equals the height. This would be the exact answer. And if you need an approximation, just make sure your calculator is now in degree mode, since we have a 20-degree angle. Then you just type in 10 times the tangent of, 10 times the tangent of 20 degrees. So we get that the height here of this triangle is about 3.64 feet. That would be the approximation. Okay, so that's essentially a review of SOHCAHTOA to find missing pieces of a triangle. Some of the directions may say to solve a triangle, which means you basically find all the missing details. So find missing angles and missing sides. Okay, and I know that you guys can do Pythagorean theorem, so if you had to find the hypotenuse here, you would just do 10 squared plus the height squared, which will be that, and then you square root it to get the hypotenuse. Okay, so actually why don't we go ahead and just find all the missing details here. Even though they wanted just the height here, let's find the hypotenuse as well. So we could do 10 squared plus 3.639, etc. squared equals the hypotenuse squared. And to get an approximation, I would actually use this entire decimal value. So I type in 10 squared plus this value squared, get my value, which is 113.24 whatever. That's equal to the square of the hypotenuse, so now you just square root that, and you get your approximation. So then you could do square root of that answer, and you get about 10.64 feet. Okay? So that would be the missing side here. And of course, if you had to find the missing angle, I mean, that's obvious that it should be 70, since all three angles have to add up to 180. Okay, so that's how to solve a triangle. If you're missing an angle, so here's another quick example. Let's say you have a ratio. We can review this real quick. Let's say you have all three sides given, and you don't know what this angle is, and you don't know what this angle alpha up here is. Okay, you can pick any ratio you want. So let's say I want to find theta, and I really like 3 and 4. So in relation to theta, 3 would be the opposite side, 4 would be the adjacent. So this can also be set up with tangent. Do tangent theta. It's going to equal opposite over adjacent. And then this is just a review of using the inverse tangent, but to find the missing angle, you do inverse tangent of 3/4. Again, make sure you're in degrees. And you get about 36.87 degrees. So then alpha would just be 90 minus that, since they have to add up to 180, so about 53.13. Okay? So you should be good at finding missing angles, good at finding missing sides, and this is all for right triangles. Okay? Within this section, again, the focus for a lot of these is going to be on application problems. So you are going to have to read some word problems. But I know that you guys can read, and I know that you guys can draw pictures. Okay? The one thing I do want to review real quick is just to make sure that we draw an accurate picture would be to discuss angle of elevation and or angle of depression. Okay, and what you need to know is that both of these types of angles are with respect to a horizontal line. And usually it's going to be the line of sight and horizontal line. So, for example, if a word problem said the angle of elevation is 13 degrees. Okay, then that means that you have some scenario where we're looking from the ground up. So we're looking from the ground up at a target, maybe top of a roof, or top of a building, or top of a tree, or whatever. And here's your horizontal line, in this case maybe the ground. This is your line of sight. Okay, so here's your line of sight, here's your horizontal line, angle of elevation is right here. Okay, so as long as you put this angle in the right spot, solving the problem should be pretty straightforward. Okay, now if they gave you an angle of depression, okay, what that typically means is that maybe you're in an airplane or something like that. So flying up here. Not the world's greatest airplane. You get the idea. And maybe this airplane is looking down at a target or a runway. Okay, and they would say something like angle of depression is, let's say, 13 degrees. Okay, so as long as you know where that angle is, again, figuring out the problem shouldn't be that bad. So if you remember what the line of sight is, which is right here, and that you always are connecting this with a horizontal line, well, if this is my line of sight, you could think, here's a horizontal line. So that means your angle of depression would be right here. Okay, and maybe this is not the final triangle. Maybe the triangle you're going to use is down here. Like maybe you want to know what the current altitude of the plane is, and maybe that's what you have. And then perhaps they give you like how far away the runway is horizontally. Okay? But the point is, as long as you can put this angle in the right spot, then figuring out the missing pieces of the triangle is not that difficult. If you remember alternate interior angles, this angle of depression could also be placed down here, and it would be the same angle. Okay, so now you have that angle, and you can find all the missing pieces. Okay, so that's your quick trig review for right triangles with word problems and angles of depression and elevation. So just being able to draw the picture and set it up should be good for you guys because I think you guys can handle the rest. Okay, so now what we'll do is talk a little bit about some other things that are in this section. So let's talk about area of non-right triangles. Okay, so here's a triangle, not a right triangle, and let's say we want to find the area. Okay, well, let's say that we have this angle given to us, and we know this side adjacent is A, and the other side adjacent to the angle is B. Okay, so we have this given information, and we want to know what the area for the triangle is. Okay, now we know that typically the area of a triangle is 1/2 base times height. Okay, but we don't have the height, so to at least get started, we'll draw it in. So our height will go straight down to the base, make a right angle, and now there it is. Okay? And now what we can do is try to figure out what this height is using the stuff that I have in the triangle already. Okay, so if I kind of just redraw this section here, I have A for the hypotenuse, I have this angle theta, and here's the height. So thinking about SOHCAHTOA, if I know this angle, then this is the opposite side. This is the hypotenuse over here. So that would be sine theta equal to opposite, which is h, over hypotenuse, which is a. So if I solve for the height, multiply by a on both sides. Now I know what the height is in terms of an angle and a side that I have already. So then I could kind of rewrite this formula and say that the height, instead of h, could be found by just taking a times the sine of theta. And if you rearrange the order here, you're going to see a formula that we typically use for finding area of a non-right triangle. And now to use this formula, you need to know, again, the things that are in blue up here. You have to know this length, you have to know this angle theta, and you have to know this side. So two sides and whatever angle they make. If you have that information, then you're ready to find the area of the triangle without having to do too much work. Okay, so for example, let's just apply it right away. Let's say this is a 60-degree angle. Let's say this is 10, let's say this is 19 feet. Let's say this is 10 feet. And I want to know what the area is. Okay? Since this is a non-right triangle, I'm just going to use this formula up here. And all I need to know is an angle and the two sides that make that angle, which I have. So I can just plug everything in. The area would be 1/2 times A, or 10 feet, times B, which is 19, and then sine of 60 degrees. So that'll be 190 divided by 2, so what is that, 95? Yep, so 95 sine 60. And since this is a unit circle value, you should absolutely just do an exact answer. The sine of 60 degrees is √3/2. So the exact area for this triangle would be 95 √3/2 feet squared. Okay. And now with that being said, we can kind of apply that to a different scenario. Okay, so let's say we're interested in finding the area of a segment. And by the way, we're not talking about a segment like a line segment. A segment of a circle, if you don't know what that is, so here we have a sector, and if you draw the chord that corresponds to the 2 points on the circle, the space between the chord and the circle itself, that is what we call a segment. Okay, so it's the region formed by an arc right here and its chord. Okay, and if we wanted to find the area of a segment, say we have circle, let's say that's a 70-degree angle. Let's say the radius of the circle is 4 centimeters, and we want to find the area of the segment. Okay? Well, there are two things going on here. First of all, to find the area of the segment, you could find the area of the whole sector, so that's in red here, so area of the entire sector, minus, and now if I subtract the area of the triangle, then that's going to be the difference, the segment area right here. So if I take the entire sector area, subtract the area of this triangle here, that'll give me the area of the segment. Okay? And to do that, now we have to recall a formula from chapter 7, I think. The sector area is 1/2 r squared theta. I'm sure you all remember that, right? And then the area of a triangle, well, we know that this is not a right triangle, but we have a formula for that now. It's just 1/2 AB sine theta. So at least this is a good place to start. We just write down the equations for them. And now what we can do is kind of plug in the information. So we have 1/2 r squared. That'll be 16. And now one thing is that this angle must be in radians. So I know that we're in degrees here in this triangle. So we got to convert 70 degrees into radians. So if I do that, multiply by pi over 180. And now we get 7 pi over 18 for our angle. Okay, so now this quantity right here, whatever that is, that'll be the area of the entire sector. And now what you want to do is subtract the area of the triangle. And now we just do 1/2 a times b. Well, that's 4. And since the radius is 4, this side over here is also 4. And here we can just leave it in degrees because we're evaluating the sine of that angle anyway. All right. I mean, I suppose you could write it as 7 pi over 18, but then just you'd have to switch your calculator back to radians if you did it that way. Otherwise, now you can just type this in the calculator and get an approximation. So if we do that, 1/2 times 16 times 7 pi over 18 minus 1/2 times 4 times 4 times the sine of 70 degrees. Just making sure I am in degrees, okay? If you hit enter, you get an area about 2.26 centimeters squared. Okay? Ooh. All right. So I have one more problem to do. It's kind of a interesting problem, at least mathematically it is. And it's going to combine what we're doing now with even more previous knowledge. Okay, so, and there's a few of these kinds of questions that usually come up, but once you see how to do one of these, it's pretty much the same method for solving these. Okay, so last example. Let's say we have, and again, I'm just going to draw the triangle, but this could be in a word problem, like perhaps we have somebody trying to figure out a height. So maybe we don't know what AB is, okay? Let's call it X. They want to know what this height is. And they're, for whatever reason, maybe they can't get close to it, so they don't know how far away they are from this point. So what they do is calculate an angle of elevation. Let's say it's alpha. Okay? And if they were able to get this side length, then we'd have no issue. We just do tangent and set up a trig equation, and we're good to go. But since we can't find that, what could be done is maybe you step back a little bit, get a different angle of elevation. So now what you have is kind of two triangles within one. Okay? And what you could do, though, is say, let's say from one point to the next is 50 whatever, feet, yards. Okay? So we have this right triangle, and our ultimate goal is to figure out what X is, what this height is. Okay? So now what we can do is set up equations. So for example, let's call this point C. Let's call this point D, by the way. All right, and since I don't know this length, BD, let's call it Y. Okay? I know typically this is Y and that's X, but it's not important. However you label it, just make sure you keep the letters in the right spots. Okay, so if I look at the small triangle, it's one that's in orange. Okay? And if I focus in on this angle alpha, I don't have X and I don't have Y, but if I look at those two sides, I can do a tangent equation and say that tangent of alpha is going to be X over Y. Okay? Now, also, when we take a step back and look at the large triangle, this angle of elevation beta, I can do another tangent equation and do opposite, which is X, over adjacent, which would be all of this side from B to C, so that's going to be Y plus 50. Okay? And now, keeping in mind that our goal is to find X, then ultimately what we have here is a system of equations. We have one equation with X and Y in it, and we have another equation with X and Y in it. It's not the typical 2x plus 3y equals 10 and x minus y equals 15 or whatever, like the usual system, but it's still a system. Okay, so since our goal is to find X, one thing that we could do is solve for Y here. So multiply by Y, and then divide by tangent alpha. And just like any other system of equations, if you know what one variable is, then what you can do is take that and substitute it into the other equation. So we're going to take this and substitute that right in there. So now I have tangent beta is going to equal X over X over tangent alpha plus 50. And I know this is kind of strange looking, but we know how to take care of complex fractions. So if I multiply by tangent alpha to the numerator and the denominator, now I get X times tangent alpha all over just X, because the tangent alpha cancels, and then plus 50 tangent alpha. All right. And now I just want to try to get no more fractions, get all the x's on the same side. So first I could multiply by this denominator. So take this and multiply the denominator to the other side. Distribute the tangent beta. So we're going to get x tangent beta plus 50 tangent alpha tangent beta. And that's going to equal the numerator, which is x tangent alpha. I know that's kind of smushed together here, but I'm multiplying this denominator to the other side, distributing tangent of beta. So now I get that. Then that's going to equal whatever's left, which is x tangent alpha. Okay, and from here, we want to get all the x's on the same side, so I'll have x tangent beta, subtract the x tangent alpha, and then on the other side, we could have negative 50 tangent alpha tangent beta. Okay? Sorry, that's really small and hard to see. Let me zoom in there. So now we have x tangent beta minus x tangent alpha equals negative 50 tangent alpha tangent beta. And since I'm looking for x, I could factor it out here on the left. I get tangent beta minus tangent alpha equals this negative 50 tangent alpha tangent beta. Then my last step is going to be to divide by this factor, just like we did, I think, when we had log problems. We did something similar to this. So now I would have negative 50 tangent alpha tangent beta all over tangent beta minus tangent alpha, and that is what the height's going to be. So as long as you know what the distance is up here, when you take your first angle of elevation back up and get a second reading, and you know what the two angle of elevations are, you should be able to find the height. Okay? The book may do something similar to this. I knew, okay, so let me just say a couple more things. Number one, you did not necessarily have to find y first. In fact, it's easier to find x because you could just multiply by y, and then now you have x equals tangent alpha, and then you can substitute that in for x over here, and then solve for y, and once you have y, go back and figure out what x is going to be, and you're going to get the same answer. Since I knew I was looking for x, I got y alone first. That way, when I substituted this into the second equation, I didn't have to go back and substitute another time. So it was kind of complicated, but I didn't have to substitute twice if I do it this way. But again, you can do it however you want. Another answer that you might see is maybe they factor out a negative in the denominator to get something that's a little nicer, but it's the same thing. If you take out a negative from the denominator, that switches the tangent beta minus tangent alpha to tangent theta minus tangent beta. So now your negatives cancel, and you just get 50 tangent alpha tangent beta over tangent alpha minus tangent beta. Okay, so either one of these is fine, and depending on how you do it, like what you solve for first, you'll get one or the other. Okay? So that is it for 10.1. So a little review of SOHCAHTOA problems, some applications, and then now we also kind of put these to use with some different problems that you have not yet seen before. All right.